Hello guys, welcome back to the new project of Coding Pie. In this video I am going to show you that how you can build machine learning web application that predict stock price. And this is project 12 out of 50 plus AI project. And guys, your support means a lot for this channel because this will motivate us and push me to work on new projects. So please don't forget to like, share and subscribe our channel. Now quickly install all the required libraries which include yfinance, NumPy, Pandas, Gradio, scikit-learn, tensorflow and matplotlib. And here as you can see I already installed all the required libraries, so it says requirement already satisfied. And some of the files are still in downloading, so it will take little bit of time. And finally I have installed all the required libraries which is up to 100 MB of file. So quickly I will move on to the next step where I used to fetch stock data first. So for this I used to import yfinance as yf, and if we're gonna talk about this, yfinance is a Python library that allows fetching historical stock market data from Yahoo Finance. Next I used to import pandas as pd, which is a powerful data manipulation Python library used for working with structured data. Next, with the usage of def keyword, I used to define a function called get_stock_data with two parameters, that is ticker and period. Ticker is nothing but it is a parameter that is used to represent the stock symbol. And here I also mentioned that default value of period is 5 year. Next, with the usage of yf.download function where I used to pass ticker and period, this line of code will extract data up to 5 years and this will be stored in data variable. Next I used to print the header with the usage of fstring. This I used to pass ticker inside the curly braces. Next I also want to show that top 5 rows of all companies data. This I used to print data.head function. Next I used to print separator for better readability. For this I used to print equal to sign up to 50 times, and /n adds new line before and after the separator. This log make easier to read when we use to fetch multiple stock data. And at last, in return statement I want to extract close column from the data because closing price are commonly used for analysis. And here one thing you notice that data with double square bracket ensure that data frame should be written, not a series. Next I used to mention list of stock tickers which include Apple, Google, Microsoft, Tesla and Amazon. And this is to be stored in stock_option variable. Finally I used to fetch and print data for all stock. So this could be done with the usage of for loop where stock will iterate over stock_options. Then I used to call a function that is get_stock_data where I used to pass stock. After running the code I successfully fetched the data, and this is how the data look like. It include date, closing price, high price, low price, open price and volume price. Now quickly I used to move on to the next step, which is pre-processed data. So for this, from sklearn.preprocessing I used to import min-max scaler. And if we're gonna talk about this, min-max scaler is a scaling tool from scikit-learn that is used for data normalization. Scaling is critical for machine learning model to treat all features equally. And min-max scaler ensure that all values are between 0 and 1. Next I used to import NumPy as NP for numerical operation. NumPy provide efficient array operation and scikit-learn relies on it. Now next I used to define a function with the usage of def keyword, that is prepare_data, where I used to pass one variable, that is data. Next I used to call min-max scaler class where I used to pass feature_range, that is 0 to 1. 0 to 1 is a range commonly used for neural network like LSTM. Then whatever value that comes after it, it will be stored in scalar variable. Next I used to call scalar.fit_transform where I used to pass data. This line of code perform scaling operation on top of data set, and then it will be stored in data_scaled variable. Finally, in return statement I used to mention data_scaled variable and scalar variable. After running the code I used to move on to the next step where I create data sequence. For this, first I define a function that is create_sequence with the usage of def keyword where I used to pass two parameters, that is data and time_steps, that is 60. This function will create input-output sequence for time series forecasting. So for this I used to define two variables, that is x, y with two empty list. Here x is nothing but it is a feature variable, whereas y is nothing but it is a target variable. X will store sequence of past price and y will store next price to be predict. Next, with the usage of for loop, I as variable iterate over the data to extract sequence. And one thing you noticed over here that inside the range function, first I calculate the length of the data, then I used to minus time underscore steps minus 1. This line of code avoid index error by stopping early. Next, with the usage of x.append function, where I used to pass data with index I colon under the round bracket I plus time underscore steps comma 0. This line of code extract a sequence of time underscore steps consecutive values. Each sequence in x serve as input to predict the next value in y. Again, with the usage of y.append function, where I used to pass data with index I plus time underscore steps comma 0. This line of code record next value after each sequence as prediction target. Finally, in return statement, I used to convert it into an array. The usage of np.array function, I pass x and y to it. Now, after running the code, I quickly move on to the next step, where I used to build LSTM model. And here, as you can see, from tensorflow.keras.models, I used to import sequential approach. This helps us to create linear stack of neural network. Next, from tensorflow.keras.layer, I used to import LSTM and dense layer. LSTM stands for long short-term memory layer, which is a type of recurrent neural network. And the dense layer is fully connected layer, which means that every neuron from the previous layer become input to the next layer. Next, I used to define a function that is build underscore LSTM underscore model with one parameter, that is input underscore shape, and this parameter specifies the shape of input data. Next, I call sequential class, and inside the list I used to arrange different type of neural network. And as you can see over here, that first two layer is LSTM and the last two layer is dense layer. In first layer of LSTM, I used to define 50 units of neuron with return underscore sequence is equal to true, which means that it will return full sequence of output. Next is input underscore shape is equal to input underscore shape. This is correspond to the feature variable. In last LSTM neural network, I used to mention return underscore sequence is equal to false intentionally, means it will only return last output in a sequence. I used to add dense layer with 25 neurons. This helps the network to learn more complex pattern. And as we know that this is a type of regression problem, this is why in last dense layer I used to pass one neuron. Next, I used to compile the model with the usage of model.compile function, where I used to pass optimizer as Adam, loss as mean squared error. This line of code set up the training process for LSTM model, and after this I return the model variable. Now quickly I used to move on to the next step, where I used to train the model. For this, with the usage of def keyword, I used to define a function that is train underscore model, where I used to pass one parameter, that is ticker. Then inside the function I used to call another function that is get underscore stock underscore data, where I used to pass ticker, and then I used to save it to the data variable. This line of code will extract all types of companies data as per as ticker. As ticker represent the short term of company's name like Amazon, Google, Tesla and so on. So I used to call another function that is prepare underscore data, where I used to pass data variable. Line of code normalize the stock market data. I used to store it to their corresponding variable, that is data underscore scaled and scalar variable. I used to call create underscore sequence function, where I used to pass data underscore scaled variable time underscore steps, that is equal to 60. This line of code will convert the time series data into supervised machine learning format. After this, I used to save it to their corresponding variable, that is x and y, whereas x represent the input sequence and y represent the output values. Next, I used to reshape the data of x into 3 dimension. This I used to call x.reshape function. I pass x.shape with index 0. This will represent the number of sequence. Next is x.shape with index 1. This will represent the time steps. And finally 1, which will represent the single feature. And whatever value that comes after it, I used to save again to the x variable. Next, I used to call another function that is build underscore LSTM underscore model, where I used to pass x.shape with index 1, 1, and that will be stored to the model variable. This line of code will return compiled LSTM model, which is ready for training. Finally, with the usage of model.fit function, I used to fit the model on top of x variable and y variable with epochs value 10 and batch size equal to 16 and verbose equal to 1. This line of code will train the model up to 10 epochs with batch size 16. Here I have to mention verbose equal to 1 intentionally, because I don't want to show the result in a progressive bar. In return statement, I used to return model, scalar and data. Now quickly I used to move on to the next step, where I used to predict future stock price. For this, first I used to define a function called predict underscore future, with two parameters, that is ticker and days. Here I mentioned the default values of day equal to 30. Then I used to call train underscore model function where I used to pass ticker. Line of code will return LSTM model, max scalar which is to be used on top of dataset, and original stock price data frame. And finally I used to store it to their corresponding variable, that is model, scalar and data. Next I used to call a function that is prepare underscore data where I used to pass data. This line of code will rescale the latest data using the same scalar. Then I used to store it to their data underscore scaled variable. Here one thing you notice that there is a underscore sign after the data underscore scaled variable. This is used to ignore the second return value. Next, with the usage of data underscore scaled with index -60, this line of code will extract most recent 60 days of scaled data. And I used to store it to their corresponding variable, that is last underscore 60 underscore days. Next, I used to reshape the data into 3-dimensional array. With the usage of last underscore 60 underscore days dot reshape function, I pass 3 parameters, that is 1, 60 and 1. This will represent batch size, time step and features. Then I used to store it to their corresponding variable, that is x underscore input. Next I used to define a variable, that is prediction, with empty list. This list will store future price prediction. Next, with the usage of for loop, I used to iterate for each day to predict. So for this I used to call model.predict function where I used to pass x underscore input with index 0 with index 0. This line of code will make prediction on top of input data. And here one thing you notice that there is a double index with 0. It will helps to extract a scalar predicted value. Then whatever value that comes after it, it is to be stored in pred variable. This value I am going to append it to the prediction list. The usage of prediction.append function where I used to pass pred variable. Now next with the usage of np.append function where I used to pass x underscore input with their index comma pred comma x is equal to 1. This line of code will act as a sliding window that drops the oldest day and append new prediction value. This will maintain 60-day windows for next prediction. So whatever value that comes after it, again it will be stored in x underscore input. Next I used to perform inverse scaling on top of prediction value. So for this I used to call scalar.inverse underscore transform function. I used to pass prediction value with the usage of np.array function. Also I use reshape function with -1, will ensure compatibility with inverse transformation. Then whatever value that comes after it, it will be again stored to the prediction variable. And finally in return statement with the usage of prediction.flatten function, this will return prediction as one-dimensional array. I used to move on to the next step where I used to plot prediction. For this first I used to import matplotlib.pyplot as plt. Matplotlib is a Python library which is used to visualize the prediction data. So for this first I used to define a function with the usage of def keyword, that is plot underscore prediction with one parameter, that is prediction. Next I used to initialize figure with the usage of plt.figure where I used to pass figure size, that is 10,4. This line of code will create a canvas with 10-inch wide and 4-inch height. Then with the usage of plt.plot function where I used to pass prediction and I also mentioned that label, that is predicted price. This line of code plot the prediction array as line graph on top of canvas. Next I used to mention x labeled as day and y labeled as stock price. And I also called plt.legend function which is used to show the label, which is a predicted price. Next with the usage of plt.savefig function where I pass prediction.png. This line of code will save the plot in a current directory as png file. So finally in return statement I used to mention file name as prediction.png. Now quickly I used to move on to the next step where I used to create Gradio web application. So for this first I used to import Gradio as gr. This is a library which is used to create a web interface. First thing first, I used to mention list of available stock options. For this first I used to define a variable, that is stock underscore options. Consists the list of number of stocks. Next I used to define a function with the usage of def keyword, that is Gradio underscore interface where I used to pass ticker and days. Then I used to call predict underscore feature function where I used to pass ticker and days. This is going to be stored in prediction variable. After this I used to make return in the form of plot. So for this I used to call plot underscore prediction function where I used to pass prediction. Now quickly I used to define a variable that is called demo where I call gradio.interface class, and inside that class I used to call a function that is gradio underscore interface which is to be stored in fn variable. Next I used to define input list where I used to mention drop down and slider. Drop down will be created based on stock options and slider will be created based on days to be predicted. And finally I used to mention title and description for this application. And in last step, I used to deploy the code on Gradio with the usage of demo.launch function, where I used to mention share is equal to true. As soon as I run the code, I will get the public URL, and after clicking on it, I will redirect to the public user interface. Now quickly I used to select the options from the drop down, then adjust the number of days, and afterwards as soon as I click on submit option, I will get the predicted result. So this is how you can build machine learning web application that predict stock price using LSTM. I hope this video is informative. Please do like, share and subscribe for more upcoming projects.